Today we're starting the gas unit, and we're going to be studying gases and equations for those and the properties of gases. So first of all, why do people study gases? One obvious reason why people study gases is that we want to be able to fly. So scientists and just lay people have been studying gases for hundreds of years. And here we have a picture of a battalion of hydrogen balloons that was used during the Civil War in hopes of being able to go behind enemy's lines and make reconnaissance missions to study the movements of the enemy troops. So here we have Union troops using hydrogen generators to fill up one of their hydrogen balloons. And that's just one example. Another reason why scientists study gases is some reactions are very important, which do generate gases or maybe take place in the gaseous state. So here's a very important reaction. Early airbags in cars actually used a decomposition reaction of sodium azide that produced nitrogen gas, and because of the heat produced from the reaction, it also produced a lot of heat, which caused the nitrogen gas to expand and then fill up the airbag in the car during an accident. Okay, so the reason why gases are different from solids and liquids is unlike solids and liquids, there is a lot of free space within a gas. Gases are also unique in that they can expand infinitely and fill whatever container they're in. So they do fill containers uniformly and completely. And the other thing about gases is if you think about perfumes, when someone sprays perfumes, the gases produced from that perfume vaporizing actually diffuse or move throughout the room that you're in. And then eventually you can kind of smell it wherever you are in the room. And that just shows that they're diffusing rapidly and mixing with the air in the room pretty rapidly. Okay, so when we're studying gases, there's going to be some different symbols we're going to use to represent some common gas properties in our equations. V will be used to represent volume, and that's typically going to be in liters. T is going to be used to represent temperature in our equation, and the unit for temperature that we must use in all our equations is Kelvin. N represents the amount, and that is the number of moles of your material. And P represents the pressure, and one very common unit of pressure is atmospheres. Okay, so let's look at the pressure of gases. When we talk about atmospheric pressure, this actually is the pressure of the gases in our atmosphere pressing on everything on the earth. So this is something you're kind of used to. So every minute you're alive on Earth, you have 15 pounds of pressure pressing on pretty much every square inch of your body. Okay, so the pressure is represented by the equation force over area. So if we think about that, so pressure is affected by two things, the force and the area. So if we think about this elephant and this girl here, and this girl's wearing some high heels, which one would you rather get stepped on by? So we have to consider both of these things. So we have to take in both of these situations the force, which we're roughly saying is about the mass, over the area. So if we divide each of these, what you will find out is that you would be hurt more by the girl with a high heel stepping onto your foot rather than the elephant. Even the elephant is obviously a lot more massive because we have a much larger area of that elephant's foot pressing onto your foot. It'd be much more painful to be stepped on by the girl on the high heels because it's over a very small area as opposed to the elephant whose foot is a very large area. So this is why, like when you go skiing over the snow, obviously, that skis are made with a very large surface area. So your weight, your body weight, is spread out over a very large surface area, and that way you don't sink down into the snow. When you go ice skating, however, it's advantageous to have it being spread out over a very small surface area, because your mass, your weight spread over a very small surface area results in a lot of pressure, and this actually helps melt the ice that you're skating on, that's in contact with the bottom of your ice skating blade, and then it helps you glide over the ice because it reduces the friction. Okay, so when we talk about pressure, atmospheric pressure, we usually measure the atmospheric pressure with something called a barometer. So this is an early version of a barometer. It was developed by Torricelli in 1643. And what he had an open dish of mercury, and the atmospheric pressure in the room, the air pressure in the room would press on the surface of the mercury, which remember is a liquid, and force up into this closed glass tube, which had a vacuum at the top. And obviously, the higher the height of the mercury in the tube, the greater the air pressure in the room. So he could measure the air pressure in a room with this. When we talk about standard air pressure, this is the typical range of pressure where most people live. So typical standard air pressure is around 730 to 760 millimeters of mercury. So we can compare this to if we went to the top of Mount Everest. This air pressure is obviously very low. It's only about 1/3 of our typical air pressure. And that's why if you go to the top of Mount Everest, it's going to be very difficult for you to breathe. Your body's not used to this little amount of air. And what we call standard air pressure, STP, this is going to be the average pressure at sea level, and this is going to be about 1 atmosphere or 760 millimeters of mercury. We live in probably slightly off from this, a little bit lower, depending on if you're above or below sea level. So if you're a little bit below sea level, it's going to be a little bit smaller than this. If you're a little bit below sea level, it's going to be greater than this. If you're above sea level, it's going to be a little bit smaller than this. So when you look at different units of pressure, we have lots of different units of pressure just because the different types of pressure readings we take and historically what units of pressure are associated with that. So if we look at something like tires here in the US, if you look at a tire gauge, that's going to measure PSI or pounds per square inch. If you look at atmospheric pressure, like we measure with a barometer, because we've typically used that barometer with mercury in it, we use something called millimeters of mercury as a unit. If you go into a lab, a lot of the readings in there on the gauges in there will be in pascals. It's just the unit of pressure in this scientific international system. If you look at a typical environment pressure that's given, like if you look at the Weather Channel or maybe some kind of like a pressure reading map, it'll be atmospheres typically. And then in industry, the unit of pressure we often see there on the gauges on the tanks there is torrs, named after Torricelli. So there's going to be different units of pressure that will be given to you in the problem depending on what kind of pressure is being described, like what it is of, and maybe how it was taken. So the relationships I want you to be familiar with are right here. So make sure you write these down into your notebook. And when you're doing a problem, it's going to be very important because there's lots of different units of pressure that you make sure that you are using the same unit of pressure if you are dealing with a problem where the pressure changes. Okay, so when we're doing calculations, we do have to make sure we're using a common unit of pressure in our calculations. So I want to look at two calculations where we're going to have to do conversions. So let's look at these two problems. So we have 475 millimeters of mercury, and we want to get that to atmospheres. So let me just bring up this, and we're going to do this problem together. Okay, so let me see now. So we have 475 millimeters of mercury, and we want to get this to atmospheres. Okay, so whenever you're doing these kind of problems, you have to go back and look at your relationships. So we see here that 1 atmosphere is equal to 760 millimeters of mercury. So I find it very helpful to set these up like a conversion factor. So we have 475, so we want to get from millimeters of mercury to atmospheres. And we see up here that 1 atmosphere is 760 millimeters of mercury. So we're going to put a 1 next to atmospheres and 760 next to millimeters of mercury. So then we multiply what's on the top, divide by what's on the bottom, and that gives us 0.625 atmospheres is our answer. And we see here millimeters of mercury cancel out. We're left with atmospheres. In the bottom one here, we have a problem where we have PSI, or pounds per square inch, and millimeters of mercury. So we're starting with 29.4 PSI times, and we want to get to millimeters of mercury. So if we go back, we see that 14.7 psi is equal to 1 atm, and 1 atm is equal to 760 millimeters of mercury. So this also tells us that, let me write this in, that 14.7 psi is equal to 760 millimeters of mercury. So we can make that argument given the information. So we see that we have PSI has to be on the denominator for those to cancel out, and millimeters of mercury have to be in the numerator. So we know from this that 14.7 goes to PSI and 760 goes to millimeters of mercury. Okay, so if we do 29.4 times 760 and divide that by 14.7, that gives us 1,520 millimeters of mercury. Okay, so that's how we would convert from PSI to millimeters of mercury. So the important thing is, if you're not given the same unit of pressure in a problem where you're going from one pressure unit to another, in order to work the problem, you're going to have to convert them to each into the same unit of pressure. Okay, with temperature, these all have to be in Kelvin to do a gas laws problem. So if you're given the temperature in Celsius, you're going to have to add 273 to get that into Kelvin. And if you're asked to find your answer in Celsius at the end, you're going to have to solve the problem in Kelvin and then subtract 273 from your answer to get the answer into Celsius after you're done. So make sure you have these written down.